user in Azure, while development is done using Visual Studio. Our simple uses a couple of simple projects based on Visual Studio templates, so you don't need much additional knowledge to create a sample. You only have to create a project using a standard template that includes all the elements to run a small project with REST API and web app using ASP.NET Core 6 technology. Now we will go to Visual Studio 2022 and we click on Create a new project. We select the first template, ASP.NET Core Web API. It's a project template for creating ASP.NET Core application using Razor pages. So we click on the first one. After Next, we need to give a name to our project, and I will give the name Simple Container Visual Studio 2022. Don't forget to verify that you have selected ASP.NET Core 6 as the framework .NET 6 is included in the latest release of Visual Studio 2022. So it's automatically installed and configured for you when you install Visual Studio. Here, as you can see in our window, we have configure HTTPS that is enabled, and we have enable Docker and Docker operating system. So, for to enable Docker, we check all the SKs and we disable configure for HTTPS. We have operating system Linux, we will select it. It depends from what you have in Docker desktop installed. So we can select Windows. If you have Windows, check it in your Docker desktop and we click on Create. Now we have our application and we can see here we need to add Docker support. As you can see here we have the target OS, Linux, Windows, so we need to add our file, but it's already added. If you don't have this file, you can add it in this way. Now we will add Kubernetes or our orchestrator. So we do the same thing, we click add container orchestrator support and we will use Docker Compose. We click on OK. And you will have another file that will be included. We need to select again the target operating system. A new file will be added. As you can see here, we have Docker Compose and we have our YAML file in Docker Compose. Let's open it to see what is included here. As you can see here, we have Docker container is ready now, and we can click on Docker Compose to launch our application and to create our image locally. So our application is building. After a few seconds we have this application. It's a really simple application, basic application ASP.NET Core that we can implement it after. Now I will check on Docker desktop. As you can see here, we have our container already created, simple container that is already running, and we will check on images, and it's here our image. Now we will check on Visual Studio 2019 how we can create a Kubernetes application using a ready template in .NET 5 in this way. If you want to use .NET 6, we follow the same steps before. Here we will search for container to look for our project template, and we have container application for Kubernetes. This template is only available on .NET 5. We will see that. So we give a name to our project name, we click on create. So we have the same steps, and here we will select Web API, for example, or MVC, but here as you can see we have only .NET 5. It's not supported on .NET 6 this template. So we select the last one, that is .NET 5. And we will enable Open API support to have Docker file in our solution. So we click on OK, create. Our project is already configured here, and we have our solution, as you can see here. Two files. We have the first file, that is Docker file, and we have YAML file. Now we will use CLI to create our application ASP.NET Core. We will open PowerShell in administration mode in our machine, and we will start checking the version of .NET version, and we will use .NET New Web API. We give a name to our application to create our ASP.NET Core Web API. Let's check our repository is created here, and we will open this solution in Visual Studio Code. We open Visual Studio Code, and we click on File, Open Folder. We select this folder, and we have our solution here. Now we will open Command Palette, Ctrl-Shift-P to use Docker image build image. This command line allows us to build our image. So we will have a new image that will be included in Docker. Here we open Docker. We try to select our image. Here we have our image, latest version, and we click on Run or Run Interactive. So I selected Run Interactive, and we will see now our solution with the URL. As you can see here, we have localhost and weather forecast. This is the sample. Let's run now Docker desktop to find our container and our image that we already ran using Visual Studio Code. Here we have our the previous one, and here we have my simple Visual Studio VS Code. I run it to be able to see our container here running. So as you can see here, we have the latest image included. Now we'll deploy the application on Azure Container Registry. Kubernetes and Azure Kubernetes Service help you orchestrate containers. The Kubernetes Container Orchestration feature makes it easy to manage workloads on the cluster. You deploy workloads by using containers built from container images to run your application within an AKS cluster. So we start by deploying the application on Azure Container Registry. A container registry allows you to store container images safely in the cloud for later deployments. You can think of the container registry as an archive that stores multiple versions of your container image. Each stored image has a tag assigned for authentication. Container registries might be public or private. Private registry requires credentials to access and download images and will be the strategy you will follow when you store container images. Containers only allows you to deploy images hosted in a container registry. Creating a private container registry will normally be part of your standard AKS deployment strategy. Now I will open Azure Portal to create Azure Container Registry. So we have the portal. We will click on Create a Research, this button in Portal Azure. We select the first one. After we click on Containers, we choose Container Registry. We click on Create. Now we need to fill our information needed to create our container registry. You select your subscription. We need to create a new research group. So I give this name. And we have the unsent details. We need to give a name to our registry, the location. So I will give a name to our registry. It will be my container, aka sample. I will change the location here, for example, Canada East or Canada Central. So I will select Canada East. We can enable availability zone. We recommend to enable the availability zone to ensure a high availability and the resilience to our container if we are in production. Here we have networking, tag, encryption, but we will click on review and create. We don't need to modify these tabs. We click on create and the deployment will be initialized. It takes few seconds to have our container registry ready to be used. Even the deployment is completed, we will go to our container registry. We will check repositories. We don't have any results because we didn't deploy any application. We will deploy our application to our container registry. We go back to Visual Studio, right click on our solution, we click on publish, we will select Azure. We can have Docker Container Registry, but in our case we will use Azure. We click on next, we choose Azure Container Registry, we click on next. So we have the list of research group. We have our container registry, we select it. After we click on publish. It's really simple to deploy our application in few clicks using Visual Studio to Azure Container Registry. It takes few seconds to be deployed and we will check that after in our portal. So we have the building of our application and the image is pushed to our container registry. Now we will check Azure Portal when the publishing is finished, and we go to a repository to check if the application is there or not. So here we have a simple container 2022 and the latest version. Now we will go to Visual Studio Code to be able to deploy our image to Azure Container Registry. We will start by building our application. We open the command palette using Ctrl+Shift+P to build the image. You can find the image name in the output of the building image command. The same can be found in the image pane of the Docker Explorer. We open the Docker Explorer and select Connect Registry under Registries group and we follow the prompt. We will choose our provider, Azure account. We enable it here. We need to provide the credentials to connect to the registry. Even connected, we can find our Azure Container Registry. Optionally, we will tag the image. In order to upload an image to a registry, the image needs to be tagged with the registry name so that the Docker push will upload it to the right registry. We added here as mentioned, so we will specify a new name. In our case, it's VS Code. The image will show up in the Docker Explorer and the registry that the image tag point to. Select this image and we choose push. If the image has not yet been tagged, you will be prompted to choose a registry to push it to, and the image will be tagged based on the section. Here we click on refresh to be able to see if we have our application in our registry. We go back to Azure Portal and we will go to repositories and we have my simple VS Code with a tag that we already added VS Code. And now we will go to create our Azure Kubernetes service cluster using Azure Portal. We go back to Azure Portal and we click on Create Research. We follow the same steps as before, so we go to Containers, Kubernetes Service, we click on Create. We will select the previous resource group. We give a name to our cluster. We will select region. I will change region now. I will select US East, and here we have the availability zone. To ensure your resiliency and your high availability, you need to select more than one zone. And here we have the Kubernetes version. After we will select the node size. I will keep this one, the standard. And we have two methods to scale. I will select auto scaling. We have here the node pools, authentication part. You can choose between service principal or system assigned managed identity, or if you have role-based access control, or if you need to use Azure Active Directory. We go to networking, and here in integration we will select our container registry. Here we have my container AKS simple. We can create another one, but we will select the previous one that we already created before. We click on create and review event validation passed. We click on create, and the deployment of our cluster can take few seconds. And now we go to our research to check our cluster. And now we will create our Azure Kubernetes service cluster using Azure CLI. To create an AKS cluster, we use AKS create command line. The following example will create a cluster named my AKS cluster name with one node. We need to specify the resource group. We need to generate our keys to be able to have administration access to our cluster after. And we need to attach our Azure Container Registry. We specify only the name. Now we go back to Cloud Shell to create our cluster, AKS cluster, and we will use AKS create. I will use the same resource group. This is the name of our cluster, one node. We generate our keys and we will attach our Azure Container Registry. We can have more than one parameters. Here I added another parameter that is related to the location. I changed the location to East US. Now the creation is running. It can take a few seconds to have our cluster, and the output will be a JSON file that includes all information related to our cluster. We go back to Azure Portal to verify if the cluster is created or not.
So we start by deploying our cluster here. The first step is to open Cloud Shell to be able to connect to our dashboard. After, we will use this information as the account set, our subscription. We need to identify that. As AKS get credential, we need to specify the resource group, the name of your cluster, so we can find these commands when you open your Azure Portal and your cluster here connects. We will see that after in detail. So we will just explain how we do that. The second part is to create an empty file called Azure Demo Deployment YAML, where we will define our deployment, and We will copy this content as an example, but it depends from your application. Here, an example of YAML file to be able to deploy my application. It's web API, it's not user interface, not MVC. It's simple. Here we have the codes, we have our container, and after we will run the application and deploy it in the cluster. We will use for that kubectl apply. We will see that after how we can call the name of your YAML manifest in this way. So kubectl apply Azure demo deployment YAML is the file that we created before, and we will use kubectl get deployment to check if the deployment was created or not. When the application runs, a Kubernetes service exposes your application frontend. In our case, we don't have a frontend application, it's only web service. But if you have many services and web application, this process can take few minutes to complete. And in the end, we will use kubectl get service command line using the watch arguments. If we have a web API, if we have web application, not web API, not the service.
Now we'll open Cloud Shell, but before we will go back to our cluster. We click on Connect to be able to get our subscription credentials and all information needed to connect to this cluster. The first one is related to the subscription. Is it account set subscription and your subscription? And the second one is related to our credentials to be able to connect to our cluster. Next, we will create an empty file, a YAML file, Azure demo deployments, where we will copy these contents that we described before in our presentation. So we have our deployment information, like the pod, like the name, and we have the image of our container, the link. We get this link from our container. Let's see how. We go back to Azure. We click on our container, repository, and we check the first repository, and we copy this link. This is your image that you will use it to be deployed in our cluster. We leave and we will use kubectl apply with the name of our file that we already created, and the deployment will be added. And to verify if the deployment was created or not, we will use kubectl get deployments.
I am Microsoft MVP in Developer Technologies, a software architect and cloud architect. I am a member and speaker in .NET Foundation. I'm also MCT and Azure certified. You can follow me on my Medium blog for more articles about Docker, Kubernetes, containers, about this topic and others. Or you can follow me on LinkedIn, and I have a YouTube channel for more video, more demo. So if you have any questions during this presentation, I will answer you in the end, or you can ask me on Twitter. So we'll start today by an introduction about Docker images. After we will prepare the environment for running containers locally. Then we will talk about building and storing images by using Azure Container Registry. And we will deploy a web app by using an image from an Azure Container Registry repository. So our demo, we will have 3 demos. The first one is about creating an Azure Container Registry with Azure Portal, and we will create the Azure Container Registry using Azure CLI. And the second demo, it will be about building a Docker image, and we will upload it to Azure Container Registry. And in the end, we will deploy a web application from Docker images. So we start by an introduction about Docker. Docker is a tool that makes it easier to create, deploy, and run applications by using a containerization approach. These containers are lightweight and take less time to start than traditional servers. These containers will also increase performance and lower cost while offering proper resource management. Another benefit to use Docker is that you no longer need to pre-allocate memory to each container. We need to understand the difference between Docker container and Docker image. So Docker container is a virtualized runtime environment used in application development. It is used to create, run, and deploy applications that are isolated from the underlying hardware. A Docker container can use one machine, share its kernel, and virtualize the operating system to run more isolated processes. As a result, Docker containers are lightweight. But Docker image is like a snapshot in other type of virtual machine environments. It's a record of a Docker container at a specific point in time. Docker images are also immutable. While they can't be changed, they can be duplicated, shared, or deleted. The feature is useful for testing new software or configuration because whatever happens, the image remains unchanged. So containers need a runnable image to exist, and containers are dependent on images because they are used to construct runtime environments and are needed to run an application. A Docker image has many layers, and each image includes everything needed to configure a container environment, system libraries, tools, dependency, and other files. Some of the parts of an image include a base image, where the user can build this first layer entirely from scratch with build commands. We have also parent image as an alternative to a base image. A parent image can be the first layer in a Docker image. It is you reuse the image that serves as a foundation for all other layers. And we have the other layers that are added to the base image using code that will enable it to run it a container. Each layer of a Docker image is viewable under var-lib docker diff or via the Docker history command in the command line interface CLI. We have container layer. A Docker image not only creates a new container, but also a writable or container layer. This layer hosts changes made to the running container and stores newly written and deleted files, as well as changes to existing files. This layer is also used to customize containers. And we finish by Docker manifest. This part of Docker image is an additional file. It uses JSON format, the format to describe the image using information such as image tags and digital signature. So if we come back to our 5R strategy for cloud migration dedicated to containers, we can see here how we can deploy it if we want to rehost or refactor, use the microservices approach if we decide to re-architect, for example, or for new application, or to replace, we have to build patterns to adopt a cloud native strategy in the future. And this image can show us how we can deploy our containers. So before starting our demo, we need to check some Docker commands that we will use it during our demo. So if you want to build an image from Dockerfile, we can use Docker image builds. And if you want to enable a user to update the configuration of containers, we use Docker updates. Docker tag is used to create a tag, such as target image, which enables user to group and organize container images. And to remove unused images, we can use Docker image prune. And to pull an image or a repository from a registry, we use Docker image pull. And we will use today push image. We use for that Docker image push. We will push this image or a repository to a registry. If you want to remove one or more images, we can use Docker image rm. And Docker image save is used to save one or more images to a tar archive. And we finish by tag that is used to create our tag. Now we will prepare our environment for running container locally and in Azure Container Registry. So we need to install Docker Desktop. It's free, so we can create an account on Docker Hub and download Docker Desktop. And this week, in 8 November, Microsoft made generally available to users worldwide its latest version of Visual Studio and .NET. And during our demo, we will use the latest version of Visual Studio 2022, and we will create an application using the framework .NET 6. So we need, in the end, to have an account, Azure account, where we are able to create an Azure Container Registry. The first demo is about creating a Docker image, and we will use two methods. The first one is the interactive method. With this method, users run a container from an existing Docker image and manually make any needed changes to the environment before saving the image. The interactive method is the easier way to create Docker images. The first step is to launch Docker and open a terminal session, and we will use Visual Studio to create our application to be able to push our images. Then we will use the Docker run command image name and the tag name. This starts a shell session with the container that was launched from the image. If the tag name is omitted, Docker uses the most recent version of the image. After this, the image will appear listed in the result, and we will check the result in Azure Desktop. And we have another method that is where we use Dockerfile method. This approach requires making a plain text Dockerfile. The Dockerfile makes the specification for creating an image. This process is more difficult and time-consuming, but it does well in continuous delivery environments. The method includes creating the Docker files and adding the commands needed for the image. Once the Docker file is started, the user setups a Docker ignore file to exclude any files not needed for the final build. The .NET ignore file is in the root directory. Next, the Docker build command is used to create a Docker image, and an image name and tag are set. Lastly, the Docker image command is used to see the created image. And now we will start our demo. So I recorded our demo to be able to check all this demo. So I will share my screen here. It's a video. So we will start now by launching Visual Studio 2019, and we click on Create New Project. Here we select ASP.NET Core Web App. We give a name to our project, and after we will change this location here, the name .NET Core Simple. I will change the location, and we click on Next. Here we will use the framework .NET 6, and I will check Enable Docker. We have two environments, Windows or Linux. I will keep Linux for now. So we will click on Create. So as you can see here, .NET 6 is the latest version. And we have this application, it's ASP.NET Core, and here we have the Docker file already created. We will check the file here that we can use it for deployment. And we have Docker to be able to launch our application. Now we will check Docker Desktop here. As you can see, when we build our application, we see .NET Core Simple is already running. And we can check our logs when we start working on the image. Now we can check our application. We check our application. We click on Docker, and it's really simple application to start. Here, as you can see, we already created. And now we open PowerShell in admin mode. And we try to go to our application. We will use Docker run. This command line here, we have the name of our container that we want created. And as you can see here, it's already created. We already run it, and we ran another one, container demo. So we used the Visual Studio, and we used the PowerShell to run our application with another name. Now we'll check the images here. We use Docker image command line to check our repository, that is the same .NET Core sample. Now we will see our containers where we can find here, as you can see, our image and the container created already. So we have container here, the first one, the second one, for the same repository. So to build and store images by using Azure Container Registry, we need to know what is Container Registry. So Azure Container Registry is an Azure server that you can use to create your own private Docker registries. Similar to Docker Hub, it offers a few unique benefits. So Container Registry runs in Azure and is highly scalable, providing enhanced throughput for Docker pools that can span many nodes currently. So to use Container Registry, we will need to create a registry by using Azure Portal or Azure CLI. We'll see that after. And we can store and host images and build images. So Azure Container Registry, store, private registry. So now we go to Azure, Microsoft Azure, Azure Portal here. We click on Create, Research. We are looking for containers here. We have container instance, but in our case, we will use Container Registry. So we click on Create. And we need to add a new research group or select existing research group here. After we give a name to our registry, so I will give a name, we can select the location and so we need to check that's not already used here. In our case, it's already used, so we change the name, Docker demo container in our case, and we can select availability zones if you want to enable it, and we have many SQI, basic, standard, or premium. So we select for now basic one. We click on review and create. Even all validation passed, we click on create. To create Azure Container Registry, it takes few seconds, and it depends from your container to create it. So we click on go to research here. We can see our container, Azure Container Registry already created. We will check our settings here. We have the repository, no result because we didn't push any images for now. So now we will try to see Shell Azure Portal to be able to create our container using Azure CLI. To do that, we open, here we have PowerShell. We can use PowerShell or Bash, so we will use PowerShell. And you can use your local PowerShell too. So here we have this command line. We need to identify our research group. I will use the same used before. And we need to give a name and to select SQI, SKU. So it's basic too. It takes few seconds to create our Azure Container Registry. As you can see, the output is JSON format. We have all information related to our Container Registry. To be able to verify this one, I will just refresh here my container, my group registry here, to see the second container registry already created. As you can see, we have the first one created using the porter, the second one using Azure CLI, and we will check the repository to no result because we don't have any image uploaded now. Now we'll build a Docker image and we will upload and push this image to Azure Container Registry. To do that, we will open Visual Studio, the previous our application, and we will use the utility of Visual Studio here. We go to release mode. We need to rebuild our application before publishing or pushing this application to as an image to our container registry. Using Visual Studio, it's the simple way, really. This is the application. We go back here and we click on .NET Simple, our project. We click on Publish. Here, as you can see, we have many targets. We can select Azure, Docker Container Registry. We can deploy here to any supported like Docker Hub, any supported container. Here we can use folder, FTP server, IaaS if you have a web server IaaS, or to import profile, to import profile. Here you can publish locally, for example. We select Azure. Here we have many services that we can use it, but we will choose Azure Container Registry in our case. We have also Azure Virtual Machine that we can use it too. Here we need to connect. Here we have the subscription name and the container registry. I will select the second one here and we click on Publish. You can also create your Azure container registry from Visual Studio if you don't yet create it. So here, as you can see, we have Docker exec. Our Visual Studio is using Docker command line. It takes a few seconds to have our application, our image, pushed to Azure Container Registry. As you can see here, we have many command line of Docker run as in here, as you can see, push it to our repository. And we will check after in the portal our repository. Now we go to the port, to our image here, to our container registry. We check on repositories here. And here we have our repository, the latest, the first tag, it's default latest. Now we deploy a web app from Docker images. We open PowerShell and we start by updating our Azure Container Registry to admin enable true to be able to log in to our container registry. So we clear here to see. Here we use the login and the name of our container. As you can see, login succeeded. And after we will use this command line to get the login server we needed to connect to our registry. Here we needed, as you can see, this command line acr-show. Here the variable login server include our login. I will check Docker image here. We have this one, but we will use the first one, .NET Core Simple. Is that what we need to push it after as to our container registry that we already log in. So here we add the tag, latest one. So we use Docker tag. We can change to another tag, for example, not least dev or other, and the image will be pushed. And we will see our repository, the list of repository related to our demo container. We have only one repository in our case, and we can check even the list of or to show all tags related to this repository. In our case is latest, but you can have more than one. You can add more than one for dev, for production, so it depends. Last week on Microsoft Ignite, they launched Azure Container Apps. It's used to build and deploy modern app and microservices using serverless containers. It's really interesting. I wanted to show you today this one as a future service in Azure that we can use it to deploy our containers. So here we have the subscription, we use the same research group, we give a name, and we have to add a new container app environment. This is the difference between this and the Azure Container Registry or instance. And we give a name to our environment name, we give a name here, container app environments. We click on create, we can select the region here, Canada, Central. We need to identify in monitoring log analytic workspace. You need to already create it before. And we click on review and create. And our container app will be created in few seconds. We can check the research and we have the application URL here, as you can see. Welcome to Azure Container Apps. You can test it to deploy your container.